Hello students, so continuing our lectures on interpolation, we will discuss about spline interpolation today. Now this interpolation method is based upon that if we have a set of points, like if we have x1 and correspondingly say x1 and correspondingly fx1 or y1 for that matter, and x2, fx2, y2 and so on, and we plot them x1, x2, x3 dot, 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 and say y1, y2 and y3. We have plots like this. Okay, so what we do here, we match the different slopes. So we have a slope around, say here, then we have a slope here. So we match the different slopes, and so by matching the different slopes we get a smooth plot. Now the question is, if we match there are three lines. First of all, if we consider a linear line, then we only are matching the slope. If we consider a cubic polynomial, then we are not only matching the slope. So for the linear, only the slope matching takes place. For the cubic polynomial, slope as well as curvature matching takes place. But going to higher order polynomials is not very beneficial, because nothing extra advantages we get, only it makes the polynomial more complicated. So the first case where we are only matching the slope is called piecewise linear interpolation. And the second one is called cubic spline interpolation. Okay, so we'll take up the first one. First, consider the equation of a straight line connecting, say there are 2 points. Say the first point is xi, yi, and it is being connected to x I plus 1 and y I plus 1. So we use this one. In this case, the function fx is equal to a1 x minus xi plus a2 x minus xi plus 1, where a1 is equal to fxi plus 1 divided by xi plus 1 minus xi, and a2 is equal to fxi divided by xi minus xi plus 1. So in general, we can write the function fx as equal to fx I plus 1 into x minus xi minus fxi into x minus xi plus 1, and this is divided by xi plus 1 minus xi. So this is for the piecewise linear relation, and if you look into this algorithm, then it's algorithm. The first step will be we need to run a for loop. So say for I is equal to 1 to n, and then read xi and fi, the function, then end for. So now it has read the function. It knows how many iterations it has to do, and it has read the first. It reads the different points. Now then it will read x, the point for which the function needs to be found out, and then it will take from the second point, that means for I is equal to 2 to n, it will write the function, but this function x has to be less than the function xi, and then you need to go to, if you give the numbers as 1 2 3 4 5, and the next part is 6, so not in here, so let it end for here, and in the sixth part, if I is equal to I minus 1, then 7 is f is equal to fi plus 1 into x minus xi minus fi x minus xi plus 1 divided by xi plus 1 minus xi. This is the last equation that we have just written. So this is this equation we're talking about. This equation has been incorporated into this algorithm. Then we get the values, write x and f, and the last one is stop. So here this step is important for I less than I plus 1. So it reads the first values, then for the second value onwards, if it is less than this xi, then it will perform this operation, otherwise it will stop. So this is the algorithm. So let's take an example. Suppose you have been given the following values. Let's say xi is 1 2 3 4 5 and 6, and fi values are 35 16, then so this is 33 16 35, then 25, then again 35, and again 26, And been asked to find out the value of fx at x is equal to 3.7. So this value 3.7, it is in between, say, 4 and 3. So we will take I is equal to 3 here. So using the previous equation, this fx f3.7 is f4, that is fi plus 1, into 3.7 minus 3 minus f3, 3.7 minus 4 divided by 4 minus 3. So as you can see, this is fi plus 1, this is x minus xi, this is fi, this is x minus xi plus 1, and this is xi plus 1 minus xi. So this is the formula. So ultimately we get the value as equal to 28. This is the answer. So again, recapitulate for this. So if we have xi values, x1, x2, x3, you have f1, f2 and f3. You have different points here. So what we do here, we join the points. So this corresponds to x1, y1, this corresponds to x2, y2, and then we manage to join the slopes. This is for the piecewise linear relation. Piecewise linear interpolation. So it doesn't look smooth. So to make it smooth, we need to, apart from matching the points, we need to match the curvature also. So that is possible only if we use, instead of a linear equation, we use a cubic equation. So in cubic equation, it takes care of the slope as well as of the curvature. So this is called cubic spline. Now we have discussed about piecewise spline in this lecture. We will take up cubic spline in the following lectures.